we have got a geometric sequence, looks like it's alternating, and what we want to do is find the sum of all infinitely many terms. Now this is going to work, of course, if the absolute value of r is less than 1. Because we know this, that if the absolute value of the common ratio is less than 1, which means that negative 1 less than r less than 1 means that this means, of course, that r is some fraction strictly between negative 1 and 1, that if that's true, then the infinite sum, the sum of all infinitely many terms, is found using this formula. The first term divided by 1 minus the common ratio. So first up, why don't we get r? So let's take the right term, two consecutive terms, take the right divided by the left. So we'll take, say, 1/3 divided by negative 2/3. This will give us 1/3 times negative 3/2. All right, so we're going to get those 3's will cancel. What do we get here? Negative 1/2. Now it looks like r is going to be negative 1/2, but let's just be sure we've got it right. We took this right divided by that left. Let's do it again. This right divided by that left. So it's going to be negative 2/3 divided by the left, 4/3. So we'll get negative 2/3 times, invert and multiply, 3/4. All right, those 3's will cancel. We'll get negative 2/4, which is negative 1/2. All right, so I'm pretty confident now that r is equal to negative 1/2, which surely means that we're in here, right? All right, so we're now going to use this formula right here. So we will get the sum of all infinitely many terms is a1, the first term, 4/3, divided by 1 minus r. Now r was negative 1/2. So we will get 4/3 divided by 1 plus 1/2. So we'll get 4/3 over, all right, this is 3/2. So now we're at 4/3 times, invert and multiply, 2/3. So what do we get here? 8/9? Yeah, so I think you add up these infinitely many terms and you end up with 8/9.